for lunch, and we are all set for the afternoon sessions. So in a while we are about to begin this after lunch sessions. So I request everyone to please settle down and please put your phones on silent mode or vibration mode. Thank you so much. Welcome back, delegates. I trust you have had enriching conversation over lunch, because the afternoon sessions dive even deeper into the technologies redefining modern combat. And nothing is redefining warfare faster than unmanned system. Drones, autonomous vehicles, robotic soldiers, swarming technologies, AI-driven combat decisions. India is no longer a spectator in this domain. We are becoming a global force. To discuss the future of unmanned warfare, we have a powerful powerhouse panel. For that, I would like to invite the moderator of this session, Lieutenant General Devendra Pratap Pandey. Served the Indian Army for over 42 years, notably as the Corps Commander of the Chinar Corps in Kashmir. He completed 7 combat tours in Kashmir and commanded units in Siachen and Eastern Ladakh. A TEDx speaker and prolific strategic analyst, he has appeared on over 180 podcasts and authored reflections on strategy. He holds a master's from the National Defence University, USA, and retired as a commandant of the Army War College. He is currently a council member of USI. He is a recipient of Param Vishisht Seva Medal, Uttam Yuddha Seva Medal, Ati Vishisht Seva Medal, and Vishisht Seva Medal. Ladies and gentlemen, we have Lieutenant General Devendra Pratap Pandey. Thank you so much. Next, I was about to say this. Next, we have Shri Yashwant Reddy, who is the CEO of Unmanned. Shri Yashwant Reddy is the co-founder and CEO of Unmanned, a defense tech startup focusing on intelligent drones for contested environments. He previously co-founded Aereo, India's first commercial drone startup, and F-Drones in Singapore, which pioneered autonomous aerial deliveries for the maritime sector. He holds a master's degree in aerospace engineering from IIT Bombay. His expertise lies in scaling drone technology across mapping, logistics, and defense sector globally. Ladies and gentlemen, Shri Yashwant Reddy. Next, we have Rear Admiral Girish Kumar Garg, specialized in gunnery and missiles during his 37 years career in the Indian Navy. He was the primary architect of the Navy's Maritime Capabilities Perspective Plan, MCPP, and the MOD's Tri-Service Technology Roadmap. His command experience includes guided missiles, destroyers, and the oversight of Greenfield Naval Base project valued at over $7 billion US. A recipient of the Vishisht Seva Medal, he holds multiple MPhil degrees and is an expert in defense acquisitions. Ladies and gentlemen, Rear Admiral Girish Kumar Garg. Next, we have Air Marshal G.S. Bedi, is a former fighter pilot with over 3,700 accident-free flying hours. He was awarded the Vayu Sena Medal for gallantry during the Kargil conflict. His senior appointments included Air Advisor in London, AOC Jammu and Kashmir, and Director General Inspection and Safety at Air HQ. He is an alumnus of the National Defence College and commanded a frontline Mirage 2000 base. He is a recipient of the Ati Vishisht Seva Medal and Vishisht Seva Medal for his distinguished service. Ladies and gentlemen, Air Marshal G.S. Bedi. And last but not the least, we have Air Vice Marshal Ashish Singh, was commissioned into the Indian Air Force's fighter stream in 1991 with over 4,000 flying hours on aircraft including the MiG-21, Mirage 2000 and Searcher remotely piloted aircraft. He is a highly experienced pilot commanding a fighter squadron, a forward base and a wing alongside various key staff appointments. Currently he serves as the Assistant Chief of the Air Staff Operations Remote at Air Headquarters. Academically, he holds a BSc from Delhi University and MSc in Defense Studies from Madras University and a PhD in Military Strategy from the School of Advanced Air and Space Studies, Montgomery. He is the recipient of Vishisht Seva Medal and Vayu Sena Medal. So, ladies and gentlemen, all the panelists, the battlefield is yours. Show us the future.
Good afternoon. I hope you don't deep dive into your seats after a great lunch. As I had less time, so I couldn't have enough lunch, and therefore I'll be quite awake. And I wish I could have given space to an unmanned system to speak about today's unmanned talk, and that would be possibly a future. Maybe I'll be lounging in somewhere beach and an unmanned system will be giving this talk to an unmanned audience. I'm a very interesting selection for a moderator, you know, because I'm an army man. I'm also from infantry. So today, on future of unmanned system, a manned system is going to be talking about. And that's a huge contradiction and a threat for future of people like us. But it's laughable but extremely serious future for which we need to actually prepare and start looking hard now onwards. From massed armies, which were about not more than about 100 years back, to precision, small, smart, agile forces, to unmanned systems, and a future of unmanned system wherein very little intervention of humans will be required, is something good but equally dangerous. And we need to look at it because the trust from man to machine is shifting very rapidly. A few broad constructs for today's talk will be the transition is today uncontrollable. So a lot of people will talk about ethical guidelines. They will say we need not do this. We must have principles. We heard today in the opening remarks as well. But the challenge is that when you start weighing with your principles, the cultural, civilizational ethos, and then you look at the bad world, you'll always find the bad world is going to win and subsume. And therefore, while we need that balance, this uncontrollable pace of transition towards unmanned system needs to be harnessed, and we need to be participatory in full-fledged. We need to actually plunge into this stuff. It is today not human-led, it is tech-led. And with AI intervention which is happening, virtually human control in evolution of technology and the way it is going to emerge. If you just take the mind-shaping system of cognitive warfare, which is the recent addition as a sixth domain of warfare, you realize that it is the AI which is going to drive. So therefore, tech is going to drive the evolution of the future tech, and humans may not be able to retain control. And therefore, as you look at future, we need to balance this out. We have no choice but to compete. We are quite a couple of decades behind, but with the speed and the pace which the first quarter of the century, of 21st century has shown, the inflection point is gone. And therefore, somewhere we need to find a way to actually leapfrog and be part of this evolution of the future of unmanned system so that we can actually keep pace with the rest. More importantly, the first and second powers of the world. Is possible. We need to possibly work hard, but I think it's doable. AI, robotics, advanced sensors, secure communications, they continue to mature and they are transitioning from remotely controlled towards tools to increasingly autonomous decision-making platforms. The future of unmanned systems is not only saving myself from doing household chores like dusting, brooming, and maybe cleaning the floors while I can deploy the robotics after my retirement, but it also requires a structural transformational change and shift for our organizations to actually use the legal frameworks which are required. We have the governance challenges which ensure that, which are halting us from progressing the way we need to progress. These issues require to be addressed very, very proactively. While the responsibility rests on the military, on the industry, I think one element which is missing in our picture is the academia. Somewhere the industry and the military has to step forward and find the governmental support to get the academia involved deeply into looking at unmanned systems, because that is where our future is going to be vested in, and we must invest in them so that they can look at our future for tomorrow. I must also share that while as a soldier and as a human, we have been at the pain point of the enemy's effect of technology, right? And therefore, we must, and at least I am quite aware today, that unlike 20, 25 years back, wherein horizontally one could hide from the enemy, you can also hide behind some cover from the vertical side. Today, humans and soldiers are naked from 360 degrees. You may like to get into subsurface, you may like to get inside the water, you may try and find the most thickest of concrete, but there are systems which are evolving, they will be able to find you, and it may not be a physical presence of a human being or a soldier to find. There are systems which are available in the world which will ensure that no place is there to hide. Ukrainians and Russians are finding hard to hide themselves, and everything which is being done is through unmanned systems. We need to focus on that. And therefore, due to the benefits of protecting human lives, exploiting civil dual-use technology, using these unmanned systems which can actually benefit maybe agriculture, maybe space exploration, maybe so many other places, but we need to use it also to military so that we can scale up, we can profit in the future by exploiting the technologies which are emerging, the cutting-edge technology that has become imperative. What I'll do is, as on my panel, we have people from Air Force and Navy, the least important today's environment, and we heard the speech today. The Air Force has taken the lead in Operation Sindoor. Indian Army used to be always the most talked about this thing, and therefore on the panel I'm the only guy who's available to talk about infantry. I'll just speak a little about the roles in which the land domain is going to be working on. I just want to talk of that we need to ensure that soldier exposure in high-risk urban, jungle, and any other terrain is reduced. We can use today very ably autonomous supply, resupply operations. We can have robotic breaching and obstacle clearing systems, which we are already developing, and they are in some stages of progress. We can always develop semi-autonomous defense system. I was deployed in Kashmir, and there were places where we had deployed security systems in the live fences where you could monitor actually sitting in a room what is happening onto the fence. But we need to go beyond all that in especially in the armed forces. And that is wherein a future lies for unmanned system. And I am looking for a machine-only tactical assault systems, which may have ethical implications, but there is no getting away from it. And I just want you to think about wherein an autonomous system can actually identify targets via AI. They can select engagement parameters. They can coordinate a swarm kind of a behavior. And they can carry out strikes with very minimal human interface. I just want to draw your attention towards Operation Spiderweb, which was launched by the Ukrainians about a year back, deep into Russia. Very little human interface. They destroyed virtually 30% of the strategic lift capability of nuclear assets of the Russians in just few hours of letting go of kamikaze drones. And they were all managed from certain degree of distance. And that is the power of the future of unmanned system. One is also looking, there's a future in maneuver warfare being conducted by ground-based unmanned system wherein they can carry out identification of enemy, they can carry out large-scale maneuver of unmanned systems to breach obstacle, breach defenses, and thereafter, possibly in some time, to continue to surveil an environment, to continue to dominate by putting certain unmanned soldiers onto the ground and secure the land space, after which, when it's completely sealed, put in human assets if required at all to capture territory, occupied territory, or even secure areas of mines, something like, when you go to looking at the Arctic or Greenland, capture of Greenland by the US, they actually don't need to use too much of manpower to actually dominate, look after that area. They just require unmanned systems. And that's the future even for land domain. I will cede the space to my eminent panelist. Almost everybody has been talked of by our speaker before me. And I'll first invite Srikanth to come and please talk to us about what has been your challenges about Aishuntam. Come. Yeah.
Thank you so much, sir. What an honor to be part of this panel. The distinguished panel members here bring a lot of first-hand operational insights from real battlefields. I don't have those many insights, but my perspective is generally shaped by, from a technology point of view, seeing what some of the world's best defense tech companies are working towards, where serious capital is flowing towards which technology, and from there projecting what might happen 5 years or 10 years down the line, thereby, of course, charting my own roadmap as a young startup to begin with. But to talk about, before we dwell into the future of unmanned warfare, I think it's only right to quickly revisit how, at the end of the day, how have we arrived at this place, right? So, there's no better place to start than the Russia-Ukraine conflict that we have all been talking about. The last few years, to think about it, right? So it's just been 3 to 4 years. But it is feeling like it's an eternity, right? So 2022 is when this conflict started, and the last 3-4 years, the kind of transformation that we've seen in the whole of defense and security landscape, unprecedented. We've not seen something like that since World War II, right? So if you think of, if I can, bring you back to the first few days of that conflict, it was extremely conventional. You have traditional tanks, artillery, mostly trench warfare and all of these things dominating, the first few days. In fact, you would recall some of the images where you would see armored columns from Russia stretching about 30 kilometers in wide open fields, right? So now here we are in 2026. That's all gone. The battlefield does not look anything close to that particular scene, because drones have simply turned the battlefield into a very, very transparent front. I mean, like Sir said, mostly soldiers are feeling naked nowadays. So that's quite a lot of transformation to happen within within just 2-3 years, right? 3 to 4 years time. And just to give you a glimpse of the enormity of this transformation, so I mean, drones have definitely far surpassed conventional arms as battlefield's most lethal weaponry. I mean, 70% of all casualties in Russia-Ukraine war, that's on the account of drones today. I mean, just to give you another perspective, what artillery has all been through the World War II, through all these conflicts, that is what drones are today, probably even more. But having said that, if I can take this conflict as a baseline, say 2022, before 2022, we all used to look at unmanned systems as, let's say, especially drones, as flying cameras, or at a higher end, flying cameras with missiles, right? They were very sparse in numbers, definitely operator heavy, but most importantly, all of our defenses, or air defenses, were generally geared towards manned aircrafts, not unmanned aircrafts. But last 3 years, what has changed is we've just seen this emergence of one-way attack drones, like various sizes, various shapes. It could be small FPV drones that can carry a few hundred grams of explosive, or it could be a large drone that can travel thousands of kilometers with 50 kilograms of warhead. So all of this spectrum, right? So this emergence of one-way attack drones has been the theme of last few years, and to an extent where I keep recalling this term called as mass beats sophistication. That has been the theme for last 3 to 4 years, where simply you just because our defense strategies haven't been planned for this new reality over the past century, all of a sudden this new threat, with sheer volume, you are able to hold an enemy who has an asymmetrical advantage in terms of their weaponry. I mean, I'm referring to Russia and Ukraine, because we never thought that this conflict would last this long. This should have been over in a few weeks into 2022, but Ukraine is able to hold fort only because of this asymmetric asymmetric threat that they hold in terms of drones. Now, what's happening today? I mean, this was last 3 years, this mass beasts sophistication. But what's happening today from an industry perspective, how I think about it is, we are in the transition phase between mass beats sophistication and a largely AI-driven future, AI-driven autonomy as a future. We are in this transition phase. And what I see, naturally, of course, EW, basically the jamming, spoofing, interferences, all of these things have become a reality, have become a default in today's environment. But what I see as happening over the next decade, that's exactly what we are also trying to focus on, is largely collaborative autonomy. Collaborative autonomy across various types of unmanned systems across multiple domains. All these systems being able to talk to each other in a very harmonious way and be able to tackle the adversary. And we'll be able to very soon come to a situation where we will definitely have drones fighting drones, certain zones managed completely by AI without even any human human involvement in decision. I mean, probably a bit of decision making, but mostly a lot of collaborative autonomy coming to the front. But in order to build this technical superiority within our country, there's a need for a large number of startups to come together and work on very tough problems long term. So nothing can be built over 6 months, 1 year. That's what I'm able to see. That's what's happening in the industry. Everyone has a very, very short view. Okay, hey, next emergency procurement 8 will come up. What is it that they need? How can I put together a system that I can just go there and get a contract about? But hard problems or technical superiority over the next decade cannot be built like that. It has to be built when large number of people are persistently solving certain long-term critical technologies dedicatedly. So I think that's what I can say about my thoughts about what's happening today and what's the right way to go about for the next decade. Thank you.
So thank you, Yashwant. Thanks for I think 3 very critical points which come out is the emergence of one-way drones. I think absolutely right. Mass beast sophistication. I think it's very relevant because if you don't have mass, you may have sophistication. You are out of the league. But most importantly, I think which is talked about is the harmonious relationship of unmanned systems. I think cross-domain linkages is important, wherein air, sea, space, land-based systems need to talk, including from recce drones to surveillance drones to the strike drones. All these things need to be harmonized and they should work. And I hope it should happen before our integrated theater commands come about. So while we are looking at theater commands to come about, we may have theaterization of drones happening before that. Girish, can I request you to join, please make a brief comment?
First class. Thank you. Esteemed co-panelists on the stage, ladies and gentlemen, honor and pleasure to be here. Since we are talking about future of unmanned warfare, it's natural for a naval officer who spent 40 years in the white uniform to speak about the future of unmanned warfare in maritime domain. But that happens to be my domain of expertise also. The scope in which I will cover my presentation is as flashed on the screen. But before we delve into the maritime domain, we need to know what are we getting into. And I must confess that I have very senior, I see in the audience a lot of officers in white uniform and very senior naval colleagues. For them, of course, this is all very, very basic. But I have pitched it not for the naval officers or the officers from the Coast Guard here, but for the academy. I see a lot of youngsters here from academia, and for think tanks, and for people from the industry, and of course, colleagues in the Army and the Air Force, to enlighten them who are looking at the maritime domain, to enlighten them as to what they are getting into. That's very important, that before you jump into the swimming pool, you know what is the depth. So it's just my endeavor to enlighten people. First is designing a shipborne drone is quite complicated compared to a land-based drones for 2 reasons. Firstly, the maritime environment is very harsh and very unforgiving. And secondly, a ship-based drone has a lot of operational and maintenance challenges. These 2 realities make a shipborne drone a completely different ballgame from a land-based drone. Now, I'll first come to the challenges of environment. Why marine environment we say is unforgiving, and why it's a challenge for drone manufacturers to design ship-based marine drones. Firstly, the marine environment is very harsh. You know, saltwater corrosion, we all know. You go for a dip into the sea, and you come back, you're all covered with salt, and you have to take a freshwater bath. You can't go to sleep after taking a dip into the sea. So salt water is very, very corrosive. You know, salt spray plus humidity combined, it damages electronics, motors, connectors, name it, it all gets damaged. So you require marine grade coatings, that is sealed enclosures, IP67, IP68. You need special corrosion resistant alloys. So it makes your life a little difficult. Wind and spray. At sea, the wind is very erratic. Unlike the land, there's a certain wind pattern. You know, wind and spray, I'm talking about the salt sea spray. It makes life a little complicated for a designer. There are strong gusts of wind on deck for takeoff and landing. So generally, the friends in the Navy would know when we pass a weather report at sea, we don't say wind speed X naught. We say wind speed X naught, gusting to Y naught. Let's say wind speed 10 knots, gusting to 25 knots. Because gusting of wind is a very regular pattern at sea, unlike on land. So when you take off and land, you have to cater for a wind speed and you have to cater for gusts of wind speed, which makes a drone design a little challenging. Water droplets interfere with sensors and cameras. Simple analogy, you go out in rain, you wear specs, little bit of drops come on your spectacles, you can't see anything. You drive your car, there are a splash of rain on your windscreen, you can't see anything outside. You need wipers. Same challenge at sea. There is a spray, there is general mist in the air, it causes challenges. Temperature extremes. Deck, ship is made of steel, iron. Decks get very hot in sun and become cold at night. Desert phenomena. Sand gets very hot in the day, extremely cold at night. Now this temperature variation causes condensation. Normal phenomena. Science, basic science. And this thermal cycling, hot, cold, it affects battery life and of course the life of the sensors. One of the biggest challenges is the platform is moving. On land, you launch a UAV, the airfield doesn't move. It doesn't move by a millimeter. It stays where it is. So UAV knows where it is to come back. At sea, you launch a ship-based drone, the ship moves. So what happens? When a ship is at sea, there's something in Navy called rolling. Rolling is this motion. It left to right. It's along the x-axis. Ship is never steady. Even you must have seen when the boat is standing tight alongside harbor, you will see, oh, hilta rehta hai. It keeps moving up and down. So rolling is this motion, X. So ship at sea keeps rolling. Pitching is this motion, up and down, along the y-axis. And then there is yaw. Yaw is this along z-axis. So a ship is moving in X, Y and Z direction constantly. Now in that you have to land your UAV. So for a manned helicopter pilot, when he lands on deck, he's trained. So what he does, he hovers over the deck. And then he watches the motion of the ship. Aise ja raha hai, aise ja raha hai. And then he watches and he sees, after some time he judges when is the ship stable and he just touches down. And then quickly you go and lash on the helicopter. But what happens for UAV? Who will do that? Pilot job. So that's a big challenge to launch, to take off and land from a moving platform which is moving in 3 axes. And the worst of all, the takeoff and landing locations differ. A UAV takes off from one position, he launches after 1 hour, the ship has moved by miles. It's not there. It's moved somewhere else. So the UAV has to keep track कि जाना किधर है, वापस किधर जाना है. In land is no problem. जहाँ से गए थे वहीं वापस जाना है. No problem. यहाँ equation is different. So the UAV has to know कि तुम हो कहाँ पर. Otherwise you'll go and ditch into the sea. That's a huge challenge to keep track of. In the vast ocean, there are no navigational marks. In land, there is a mountain, building, ye, wo. You can have reference and then you can land. At sea is all white. So it's a huge challenge. As I said, ship motion synchronization, that X, Y, Z ship is rolling, pitching, yawing. You have to synchronize and make sure if you touch, when the ship is like this, you'll go into the sea. You touch, you land, when the ship is like this, you'll go into the water. So you have to ensure you land when it's like this. It's a challenge. It's not very easy. So you require real-time motion sensors, which senses motions. What the pilot is doing, the sensors have to do the job. And then you need high-speed control algorithms to guide you. Then there are space constraints on the ship. There's a small deck. It's not you don't have a freedom of a runway that you can take it's a very small, restricted space. And if you're not precise, you'll go and crash into the ship structure because there's an obstruction point. It's not like a airfield, thoda aage piche bhi ho gaya to chalega. You don't land here, you land thoda aage, thoda piche, left, right. Yahan nahi hai. Yahan thoda sa bhi aage piche gaya, you'll go and crash into the ship structure. So that you have to be really, really precise. Precise landing is difficult because there's wind, there is gust of wind, rolling, pitching, yawing, ship is moving, everything is happening, and in between you have to land safely on that small deck. Storage is limited, hangar space is limited, so the drone has to be small, compact, foldable. It can't be, size is not your luxury. And of course, with the compactness in size, there are challenges of weights. Then there are maintenance challenges, huge challenge. At sea, you don't have workshops. There's no spare part. You just carry whatever little bit you carry with you. This is the spare you have. Beyond that, there is no what we call shore support available. You are in the middle of the sea, something packs up. If you can't sort it out then and there, just too bad, pack up and then you have to abort the mission and go back to harbor. No technicians, whatever related 2-3 people you carry with you, they are the technicians available. If you require beyond that, just too bad. So no external support. In land, you can call, people can fly down, people can drive down and sort out your problem. At sea, there is no way. There is a problem, you can't sort it out, just too bad. So therefore, drones must be rugged, they should be modular, they should have easy field repair. I should be able to repair it right down to the bare component on field. And of course, best is that they should be low maintenance. Navigation challenges. GPS has multipath effect on water because water reflects. So you find challenges in GPS navigation. Ship's hull is a huge hull, thousands of tons of metal. It has its own magnetic field. We have degaussing system, something, naval officers would know. There is a degaussing system which nullifies the magnetic effect of the vast hull, but still there will be some challenges in magnetic interference. Then there's radar clutter from waves. In naval terminology, it's called dead range. That means because of the clutter from the sea, a certain range you cannot see. It's called dead range. You are blind there because of the clutter from the sea. So that for a drone, that is a challenge. Over land, drones use terrain mapping and visual cues for navigation. But at sea, there is there is very poor visual reference. You have only water, white. It's a sea of white. There is no landmark there. So visual reference is not there. So navigation at sea becomes a challenge. Then there is RF interference. Warships have dense radar and communication emissions. I'll show you another picture to see how much of RF emitters are there in that small area of 50 to 100 meters, not even 50 or 60 meters around the helicopter deck or helo deck, what we call. I'll show you how it's a dense RF environment. VHF, HF, UHF, kilo band radar, India band radar, Sierra band radar, Kilo Alpha, all kind of radars, entire band, all VHF, they're all transmitting within that small range of 50 meters from the way you're launching. So you see the RF interference. Of course, it has its own electromagnetic interference, which affects, all this affects your GPS and control links. I'll show you a photograph. You see this photograph. I'll just show you. This is the place. This is not for my naval friend. They laugh at it. This is basic. This is a helideck where the helicopter or the UAV land. You see this. You see, this is a radar, 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 this is a radar. All these dandas that you see are all VHF, UHF antennas. This is antenna. You see the dense electromagnetic environment that is there when this UAV lands here or takes off here. So he has to cater for all these. They are all emitting. In a combat situation, all of them will be emitting. Radars, communication equipment, they will all be emitting. And this gentleman has to land without getting interfered by all these parameters. It's not easy. Oversea, there are no distinct landmarks I brought out. Repetitive visual patterns. Even trained pilots get nightmares when they think that they have to fly over the sea, because you lose your orientation very quickly at sea. You look left, right, upper, niche, wherever you see, there's only sea. You turn around, I close your eyes and I turn around 360 degrees, you will not know where to go now. There is no visual reference. Reflective glare, see, sunbeams, they have a reflective glare. It affects optical sensors. Radar sea clutter complicates tracking, I brought out. If you're tracking a target, you find you get ghost eco images, ghost images. When all of us who have tracked radars, targets at sea, there are a lot of false ecos because they generate from the clutter of the sea. So this affects autonomous navigation, target identification, and collision avoidance. Because you get ghost ecos, you don't know who's real and who's ghost image. And then you have to have that intelligence to decipher this image or this eco is real and this is a ghost. Both move at the same speed, both move in the same direction. Now you have to be intelligent enough to decipher that I have logged on to a false target and I have not logged on to a ghost eco. These are all real life challenges that. So why it's so hard? To sum up all this, what I have said, if I have to, somebody ask me, oh, kya problem hai? So you see, a ship-based drone must have aircraft level autonomy. You should be able to fly by wire on your own, autonomous. helicopter level landing precision. That means you should do what a pilot is doing. He's trained for years to land on the deck. Your UAV should be able to do that precision. It should have marine level environment durability. It should have military grade communication security. But ये सब तो हो जाएगा. Problem क्या है? Challenge is all within tight size and weight limitation. That is where the challenge is. If I give you a ship of 1,000 meter by 1,000 meter, you may be able to do all these. You will make a huge UAV. But the problem is, I showed you the deck size. That is where you have to take off and land and do all these things. So now core challenge in one line, achieving reliable autonomous landing on a dynamically moving deck in adverse weather under electromagnetic interference. If you can solve this problem, you will be able to negotiate the challenges of designing a maritime UAV. Now, so now that we understood the challenges that we get into it, so now I just like to brief you about the transformative technologies in unmanned vessels in the maritime domain, what we are seeing as of now. Now, integration of artificial intelligence and machine learning. We are seeing AI, ML in every field, you know, so the maritime world is not far away from that. There are systems which are having fully autonomous navigation. That means, I'll just take 2 minutes. And real-time decision making, obstacle avoidance, adaptive mission planning, this is self-explanatory. Sensor fusion is happening, all the various sensors are getting fused. So it enables better object recognition and behavior prediction. Algorithms are allowing drones to learn from experience and improve effectiveness over time. And AI-driven autonomous submarine hunting. Submarine hunting is one of the biggest challenges that we have in the Navy. There's a deep, dark world down below. We don't know what's happening. Our underwater temperature and pressure profiling is very different. It's a huge, huge challenge to detect a submarine underwater, especially in our waters. And AI-driven autonomous submarine hunting is a huge boost in this direction in anti-submarine warfare. So, you know, it is reducing operator burden and enabling complex operations, even in contested environments where communications are not available. Other is swarming. You know, swarms of unmanned aerial vehicles, surface vehicle, and underwater vehicles are acting in concert with each other. Swarm tactics, somebody discussed the swarm tactics in Ukraine war. We've seen that. That's what is the future in the maritime domain also. And the cross-domain linkages. That means our UAV share data with USV, USV shares with the UAV, UAV shares with the satellite, and then there's a whole network ecosystem which is working. This is exactly what I wanted to say here, that this will lead to a truly networked warfare at sea, where all three air, sea, and air surface and subsurface are combined. We are seeing extended endurances at sea, various propulsion systems. So longer endurance, of course, will allow longer persistence over the naval task force. Weaponized drones. Now that's the future. They are weaponized drones. And you have seen the Ukraine war, the Sea Baby drone. It's underwater. It went and struck deep inside Ukrainian Russian harbor and destroyed a low-class submarine. It navigated the complex environment of a harbor and navigated successfully and went and destroyed a submarine which was berthed alongside. So that's the future. So big picture, in the next decade, unmanned maritime platforms will evolve from adjunct tools to central elements of naval strategy, capable of autonomous decision making, extended missions, high survivability, and coordinated cross-domain engagements. I see very soon the Navy will have a seabed warfare doctrine. We don't have a seabed warfare doctrine because we don't know how to fight in the seabed domain. But with this underwater unmanned vessels coming, I see very soon there will be a seabed warfare doctrine, and you will hear about it in the years to come. Use of unmanned surface vehicles and unmanned underwater vehicle for sea denial. There is a concept of sea denial and sea control. It's a concept of warfare. I see now, you know, these USV and UAV being used extensively for sea denial role. And the unmanned systems force like Ukraine, General Pandey mentioned that we need to now have a dedicated command, like we're having Tri-Services Command, a dedicated command where we just concentrate on undersea warfare. Ukraine has taken the lead with this USF. I think we also need to progress in that direction because that's where the future is. Now just one slide on Atmanirbhar Bharat, because that's what it says, that we need to have a roadmap. The first thing in Atmanirbhar Bharat for ship-based drones is to design autonomous ship landing and takeoff. As you have seen, without that, there is no way forward on ship-based drones. So the first start point is to design autonomous, the word is autonomous, ship landing and takeoff. Every startup that I mentor, I tell him, he says, sir, मैं marine drone बनाना है. I tell him, सबसे पहले autonomous takeoff or landing बनाने का सीखो. Then you come to me, I'll tell you what to do next. So that's the first step. Then of course, develop ruggedized marine UAVs, develop unmanned underwater vehicles. Again, I mentioned unmanned underwater vehicles are very, very crucial. That's one area where our strength is weak, and we need to do both armed and unarmed. Maritime multi-drone domain integration, which I mentioned. And of course, there are a lot of initiatives like IDEX, Swawalamban, Meher Baba competition by the Air Force, Technology Development Fund by DRDO, ADB by Army. These all need to be strengthened, and I'm sure as we progress further, we'll see more of this. I finished. I'm sorry, I was rushing up because I was running against time. General Pandey reminded me twice that I have run out of time. So I just rushed. Whatever questions you have, I'm sure we'll be able to answer in the question answer session. Thank you.
So Girish happens to be my NDC course mate. So he got twice the time which I was allotted to him. But essentially he's, in the end, he's given a roadmap to Shri Yashwant Reddy ji, that what he actually aspires for the Navy from his unmanned group of industry which they must produce. But I will just summarize key issues. I think he highlighted very secondly the peculiarities of the maritime domain, in which harsh marine effect environment which is there, which is extremely challenging and difficult for unmanned systems for not only designing but also for maintenance. The next, he's talked of the moving launch and recovery platform challenges, and I'm sure that AI systems, when taught well enough with enough data, may be able to manage over a period of time. But I think the summary which he made, that there should be, the ship-based drone must have aircraft levels, autonomy, helicopter level of landing precision, and marine level of maintenance. I think he's asking for all the bouquets, a bouquet which has got all type of elements which are available. Thank you so much, Girish. Thanks a lot.
Thank you so much, sir. Now, before we proceed, again, rasm adaigi hai hamari ek choti si. So for that, I would request Air Marshal G.S. Bedi sir to please felicitate all the panelists. Yeah? Yes, we did.
I know, it's a break. It's a break. It's just a break.
Of course you will. And now I request Lieutenant General Devendra Pratap Pandey ji to please felicitate Air Marshal G.S. Bedi. Shall we continue the business now? All right. Thank you so much. Over to you, sir.
Yeah, can I request Air Marshal Bedi?
Thank you, Chair. Thank you for the opportunity. Ladies and gentlemen, good afternoon. Thank you that you didn't ask me a specific question, because in any case, irrespective of the question, I would have said what I want to say. And what I learned from, Admiral Garg is that if you wish to keep yourself safe from UAVs, you must go to sea and fight. It's very difficult for UAVs to get there and do something. But now, we are talking of future of warfare in unmanned domain, or, future of unmanned warfare. A lot, this August audience knows what happened in Russia, Ukraine, or, various other conflicts. So just to kind of wrap it up, my endeavor will be that how are we going to look at, this domain or unmanned warfare in the future in our context. That means India has its neighborhood, and if India has to get into conflict, then how does it come on top? Given the environment, the ecosystem, the advancements, and the strategies that we have. So now, we all heard it is, they are cheap and expendable drone systems, creating persistent ISR, and continuous threat presence than episodic engagements. Okay, then what they do, they increase not only the horizontal depth. It's not that you see thousands of drones, swarms horizontally. They create vertical depth as well. You can have a drone almost at every level. And they create the type of depth as well. You look at fighter aircraft, there is a limited depth. I mean, from smaller aircraft to larger. I mean, in today's inventory, if you see India, from Tejas to Rafale to tomorrow MK, there is a depth. But in case of drones, from mosquito size to predator, I mean, you can have drone of every size, of every capability, of a very vast depth they create in all three domains. Then your, Mumti or CATS kind of systems, what have they done? They have formalized the division of labor. They say that, okay, who will do what, while the man controls the judgment making and they undertake the high depth penetration. A single, a system can do your ISR, CAD, DAD, strike, EW across a wide footprint. So the warfare has become more of, platform rather than platform centric. It has become network and rhythmic centric. You can do dynamic retasking, rerouting around threats, cooperative engagement, etc., etc. And what happens is that humans from, trigger facilitators have become managers. A very wide area of judgment they will control. And what happens is it's from human in the loop, it has become human on the loop. So this is the wide game of, what I call the capability they bring. Now coming to the crux of the matter. So how does India play its game? It's fair enough that yes, you will be seen, there will be transparency, you can't hide yourself. But the point is just to draw a simple analogy, you play hockey game or football game, all players are watching all other players. You still play a game. You play games by the rules, by the strategy, by the skills. So even if tomorrow's battlefront, all of us can see everybody, it's not that you will stop playing. You will play, but you will play differently than you're used to playing. So game is to learn that form of playing well in advance. What are the two unique capabilities that drones bring? We are talking of drones. After all, this whole gathering is sitting here to listen to this. There are two unique characteristics that drones bring with themselves. One is depth of magazine, implying that numbers, you can generate large numbers of them. And today also, whenever we talk of drones, invariably it is the number which shadow the discussion. That 10,000 drones in 1 month, millions of drones launched, billions are being produced, etc. what they can do, the lethality part is talked about, but a little bit in the shadow of the numbers. Even the Ukraine, that spider web, if we talk of, it's not only the drone capability. I mean, single drone couldn't have achieved what it achieved by total ecosystem. After all, they were, carried to the destination, to a place, hoodwinking, everything else. That is a complete ecosystem. But the drones, if they are available in large numbers, they are cheap, then that is the USP. And point number 2 is, the second characteristic is adverse exchange ratio to the enemy. Means that you have to employ a very, very large defense system to counter a cheap drone. Now, question is not, you can't compare the cost of your anti-UAV system with the UAV, because it's not how much that UAV costs, but it is what damage can that UAV do. Whether it is a simple knife, it can come and kill me, then it's my value which is at stake, not the value of the knife. So the defense that I employ in the form of a revolver or a gun, etc., is not as compared to the cost of the knife. It is as compared to the cost of me, that how valuable I am to defend myself against that knife. So that is the system I need to employ. But the fact is, you're forced to employ this system. So if India has to play its game well, what does it need to do? Any country for that matter. But we will just, scan this scenario. We have to see our neighborhood, we have to see China, we have to Pakistan. We have been seeing, two-front war. We have been talking of that, okay, what if two-front war is imposed on India, implying that both China and Pakistan open their front. Now, which has become a reality in a single front war, because we saw in Op Sindoor that we were practically fighting China in Pakistan. So it's not that China has to open its front at the border. It can very well exercise its air power or whatever power through Pakistan in a limited area conflict, just with a front of 50 or 100 kilometers. So now, you've heard of concept A2AD, which has access and denial, 2 elements. So what do you need to do in that, credible A2AD concept? You have to deny access to the enemy, and you have to, refuse access to the enemy, and if he gets access, you have to deny your VAVP to him. At the same time, ensuring that you have this available. That means you are denying, whatever you're denying the enemy, you have availability of that. So what happens in terms of drones? In drones, it becomes that you must have large numbers available for yourself. Large number, how will large number become available? Yes, you can tell industry that, okay, make more and more, drones, but your ecosystem has to cater for it. Will they be able to sell all those drones which, 100 or 500 startups make to the Indian Defense Forces alone? Or do we need to tweak the, procurement systems or whatever you call? Do we need to go collaborative? Is it worth to tell every startup that you make full drone and give it to me? Or you tell startups that, okay, one guy makes only propellers, one guy makes only ECS, one guy makes only autopilots. And now somebody will assemble it anyway. I mean, there is no problem in assembling, but the scale will go up. One guy is making too many of them. And when you're able to make large number of drones, your logistics, your supply chain, has to remain effective. Because if tomorrow war breaks out and you need large number of supply, then you need to, continuously be able to manufacture drones in the large numbers, because otherwise one day you will launch large number of drones and the second they're not available to you, then the game is lost. And what happens to the adverse exchange ratio? You have to develop systems which can take down drones, easily. We are coming to counter drone systems. Now, while we are, talking in great detail about manufacturing drones or etc., not so much emphasis given to counter drone system. You go to any Aero India show, last one, every stall will have a drone system displayed, but very few will talk of anti-drone systems, And now, if we are talking of that even enemy is going to have drones in large numbers, and we do not have anti-drone systems, because it's not your drone fighting drone. Unlike aircraft, which 2 aircraft can get into dogfight, that scenario is not yet there for the drones. You need credible anti-drone systems. And what kind of anti-drone system? Not only RF jammer, not only DW, not only GPS spoofers. You need kind of airborne interceptor. Your drone, enemy can hide drones behind the building. Your ground radars will not see them. You need to get your radar up in the air. Like any fighter aircraft today, will it be worth it if it did not carry an airborne intercept radar? In spite of having AWACS, in spite of having number of ground-based radars, but still you will not launch an any aircraft up if it does not carry an air defense radar or airborne intercept radar. So your counter UAV system, you have to enable it that it can get airborne and look at, be autonomous. That is what autonomy is, all about. So if you don't have these capabilities developed, you are probably not future ready. And now coming to China, two comparisons I will make. We are talking of MUMT. It comes to the question of now creating ecosystem, secure communication. What happens in MUMT or combat air teaming system? You have a manned fighter, probably LCA based or, any aircraft that comes up tomorrow, and a number of loyal wingmen or, unmanned systems. Now, if I have a fighter aircraft and 10 unmanned systems which I am controlling, how am I communicating with them? It's through communication, it's through data link. And if your data link is not secured, you have lost the battle. I mean, you can put a guy up with demonstrative purposes that yes, over a Pokhran range I can demonstrate that one manned aircraft controlling 10, but in the battlefield, if I do not have the secure RT, if I do not have a mature SDR system, then if that communication is, not taken care of, then you have lost the battle. Okay. Now our system, CAT system, I feel where when I compare it to China, mothership system, China has a concept of, Geocean or jet tank, I think, aircraft. It's a, huge aircraft which will get airborne, launch multiple swarms or multiple drones. Its same is to influence area far, flung areas, project drone power into far area. Whereas our system, which is, MUMT or, what we call man-unmanned teaming, essentially operates on dynamic, tasking with human in the loop. That means there is a bit of edge computing in terms of human being available in the system. And if the availability of this human being in the system makes it a much more potent force than just an unmanned system launching drones and, guiding elsewhere. But yes, we need to accelerate. Their program is far ahead than our MUMT or, CATS system. But if India, can combine mass-produced offensive and defensive devices, a hardened and AI-enabled command control network, rapid MUMT and CATS induction, and deep doctrinal or joint reforms, it can turn its geography and growing tech base into a decisive advantage in any of the future drone-dominated conflict in the region. We have a great geographical advantage in terms of depth vis-a-vis our immediate western neighbor. So no drones probably, unless you do Ukraine kind of operation, can affect your deep down areas. So your drone manufacturing facilities, your mass scale production facilities can relatively be safe against drone attacks. Yes, they will be susceptible to missile attacks, but then you have to work harder on that. And the industry needs to work more on software driven advancements, not only generational changes. Like it's not Gen 4, Gen 4.5, Gen 5. It's the same, system which with software driven, you need incremental changes so that, the game changes. Your same machine is a new machine just because you have tweaked the software slightly. I will stop here and happy to take on any questions further. Thank you very much, ladies and gentlemen.
Thank you, Air Marshal Bedi. I think a few things which you highlighted very clearly. The feature of unmanned warfare is the Indian environment with the active borders wherein the vertical depth and horizontal depth both matter, and the sizes which you are identified about